previous lectures, we have spoken about how to develop and test ideas for products and services, and in particular, how to make sure that in building these products and services, we always keep potential customers in mind. Unfortunately, history gives us a number of examples of great innovative products that did not succeed, despite being welcomed by customers. Ironically, when entrepreneurs have in sight how to give customers a high-performance product, they often tend to neglect the importance of partners in accomplishing the solution. In this lecture, we speak about everything from how to align the partners around our company to making the innovation a success. Let's take the case of Sony Reader. In 2004, Sony was the first to launch a complete e-reader device to the market. They had a well-known brand, a partnership with the company who invented the passive e-ink technology that made the e-reader possible, as well as significant in-house resources to deliver what, functionality-wise, was a remarkable product. Branded under Sony, there was also no problem getting the reader stocked at electronics stores. But what was missing was content. For Sony, organizing that buyers of e-readers also had convenient access to a large variety of digital books was a considerable challenge. Why? Books are controlled to some extent by authors, but even more by their publishers. And convincing publishers to digitize their books was very difficult for at least two reasons. First, publishers were worried that ebooks would significantly change how their business works. Uncertainties included questions like, how would ebooks be priced? Will the publisher end up earning less than on physical books? Or, how are intellectual rights managed? But perhaps even more importantly, publishers worried that Sony could not guarantee that the books, once digitized, are not pirated. The fact that the books had to be first downloaded and then placed on the reader via a computer made publishers afraid of the possibility of them being printed or shared between many users. The traditional publishing industry was simply not ready to undertake a radical shift towards digitized books. So logically, they chose to stay with physical printed volumes. Sony launched the device with only 10,000 books available for purchase, and they were unable to significantly grow that pool. The reader itself was great, but the lack of an overall experience made it a failure. Along came Amazon with their Kindle in 2007. Kindle was an inferior product, and even 3 years later had less functionalities. But Amazon launched it not as a device, but as a service that aimed to provide customers a convenient reading experience. What did they do differently? Amazon understood the importance of making sure that all their partners are happy to play along. In particular, they made Amazon ebooks directly downloadable to Kindle devices so they could not be printed or distributed to additional users. They also made sure that the publishers are financially happy by paying them the same royalties that they would get from physical book sales. Meanwhile, customers were attracted to buy the device by selling digital books significantly cheaper than physical ones. How was that made possible? To support the adoption of Kindles, Amazon chose to subsidize the losses on book margins from the sales margin of the Kindle device. Consequently, before the launch, Amazon was able to convince publishers to digitize a total of 90,000 volumes. This pool was further extended to over 300,000 shortly afterwards. The Kindle value proposition was made possible by a well-balanced system of components, where providers of these components were well taken care of. We learned thus that the success of individual innovations is almost always dependent on complementaries that originate from other organizations. The way these organizations act can make or break our innovation, so it comes down to us as the innovator to make sure that these other organizations also play along. A significant part of launching an innovative product or service is then to consider who are the critical other organizations and what can we do to pull them along in support of our innovation. To gain that understanding, we use a tool called the Ecosystem Pie Model, or abbreviated the EPM. On the course toolbox, you find several examples and a tutorial that introduces the tool more elaborately. For the moment, let us focus on one of these examples in a simplified case that originates from Eindhoven University of Technology. Scientists at Eindhoven University of Technology invented a new concept for storing electricity as formic acid, which is the liquid that ants emit to irritate our skin. Here's how the technology works. When excess renewable electricity is generated, it would now be stored not in batteries, but as liquid fuel. This makes the transportation and storage of excess electricity quite convenient. Then, when there is demand for power, the formic acid can be converted back into electricity using a special kind of reactor. This technology is environmentally highly sustainable as no greenhouse gases are emitted in the overall process. But the key question is how to bring it to the market. In this case, the technology team at the university, called Team FAST, decided to target uptake of this technology in powering public transportation. There's one big hurdle though, one that is typical for many new technologies. That is, there already is a working public transportation system which operates quite well without this innovation. How then to get the new technology adopted? Let's first see who are the actors involved in accomplishing public transportation at the moment. First, we have of course citizens who demand a public transportation service. Led by that demand, municipalities organize competitions between transportation operators to offer the service in a certain area. Transportation operator companies in hand need vehicles to run their bus lines, so they are looking for good offers from manufacturers to supply them with buses. Furthermore, having buses is not quite enough. The bus operator also needs an affordable source of fuel to power the fleet of buses. In most cases, that would currently be diesel. Now let's assume that instead of fossil fuels, like gasoline or diesel, the public transportation system would operate on formic acid. How would the current system need to change in order to accommodate this difference? First, bus manufacturers need to adopt a new power drive to their vehicles. Second, instead of running on gasoline or diesel, the buses would run on formic acid. So petrol stations need to start offering that. Further, the fuel needs to come from somewhere. Thus, a chemical factory needs to find it attractive to produce large quantities of formic acid using renewable energy. Turns out there are several parties that need to change their activities quite significantly. And by default, none of these parties is keen to change their behavior unless there is good motivation to do so. So, if Team FAST wants to make formic acid-based transportation a reality, they somehow need to create a motivation for several other actors to play along. Here is one of the strategies by which they can do so. We may notice that the initial order for public transportation comes from the municipality. Thus, if the municipality in their tender demanded environmentally highly sustainable approaches to public transportation, there would be an incentive for bus operators to acquire low-emission buses. Demand from bus operators would in hand send a signal to bus manufacturers that fossil fuel-based engines need to be replaced with something else. And yes, there are several alternatives for powering buses more sustainably, including, for example, biogas, batteries, or supercapacitors. But at least the formic acid approach would compete now with less alternatives than before. Furthermore, the impact for petrol stations is less if only 1 or 2 stations in a city are providing formic acid for buses. Since public transportation usually revolves around a few central stations, using a limited number of formic acid stations is needed in this application. Unlike, for example, if the technology was placed into regular passenger cars or trucks, which have to be able to drive long distances in whichever direction. So although problems remain, Team FAST would have a strategy to get the technology adopted. A strategy which concentrates on working with these municipalities that have sustainability high on their agenda to organize bus tendering in such a way as to empower the uptake of formic acid-based mobility. What is important is that as technology developer, Team FAST cannot just wait and hope for the uptake of their innovation. Nor is it enough to attempt to convince their immediate customer, the bus manufacturer, to incorporate the formic acid solution to their vehicles. Under current market circumstances, they probably wouldn't. Instead, the team needs to look at the bigger innovation ecosystem. They need to understand how each of the actors in the current public transportation ecosystem operates. What is their motivation and how to get them to play along in moving to a formic acid-based solution. Only then can the team decide what exactly to do to create widespread support for the technology. Innovation ecosystem analysis of this kind is a critical step in developing your business case. Whatever we do, our innovation is dependent on many external parties, and it is our job to make sure that they are on board. In fact, in analyzing an ecosystem much the same way we just did, we may come to realize that it is very difficult to create ecosystem support for some innovations. That would be a valid argument to delay a project, or perhaps to choose an entirely different application to commercializing our technology. But we wouldn't know unless we started analyzing the innovation ecosystem as early in our development project as possible, and continued doing so throughout the process of bringing the technology to market. The Ecosystem Pi model is your decision support tool for innovation ecosystem-oriented strategy. Learn more about the use and usefulness of the EPM tool from the guidelines document on the course toolbox. Thank you for your attention and have fun finishing the course.